I think never mind. Friends, there are 10 students now. That's good. Okay, I am unable to upload the question paper, but I can read it out for you. Don't worry. Let me go one by one question paper. There, I had uploaded it right now, but some mismatch is happening. Never mind. I will show you the. Give me time. I will read out the question paper for you. This is a question paper from. This is from December 2014 to January 2015. This is a January 2015 question paper. Okay. In this, first question, define metrology, state and explain objectives of metrology. I think we have already defined what metrology is, what are the importance, what are the objectives of metrology is. If you wish, I can just go through this PDF file, have a look, what is metrology, what are the objectives, and look, just a minute. Yes, what is metrology? Metro means, yes, here is the definition. Can you say this? This is the first question. What is metrology? Metrology word is derived from two Greek words such as metro, measurement, and logy, science, science of measurement, which includes all aspects, both theoretical and practical with reference to measurement, is called as metrology. Measurement, it is the process of comparing two comparatively unknown magnitude with a predetermined standard. What are the objectives of metrology? This question carries how much? This question carries 6 marks. Okay. Objectives of metrology. Basic objective of metrology is to determine whether a component has been manufactured to the required specifications. The basic objective of metrology are as follows. 1. To provide required accuracy at minimum cost. Next, through evaluation of thorough evaluation of newly developed products to ensure that the components are within the specified dimension. To determine the process capabilities, to assess measuring instruments capabilities, and to ensure that they are adequate for their specification, for their specific measurements. To reduce the cost of inspection by effective and efficient utilization of the available facilities. To reduce the cost of rejection. Metrology, today's times, the components are very expensive, so the more is the margin of profit is very limited. So the more number of rejections, more is the losses. Companies cannot afford to do that. Any amount of effort is less to see that is worthwhile if you are able to reduce the rejections. To assess the manufacturing instruments capabilities and to ensure that they are adequate for their specific measurement. To reduce the cost of inspection. To reduce the cost of, one is rejection, another is rework. You have supplied an oversized component, again it will be sent back to you, you will have to rework that. Again it involves the machine, the main machine, and the material. Material is anyway going to be wasted. So instead, you try to manufacture a component which is within the limits of acceptance or the tolerance. To reduce the rejection, to standardize measuring methods by proper inspection methods and developments at the development stage itself. To maintain the accuracies of measurement through periodical calibration of the measuring instruments. Calibration is an equally important part. So we are discussing about calibration in the other side of our mechanical measurements and metrology. In metrology part, much of our discussion is on calibration of the instruments. To prepare the designs for gauges, yes, I have discussed this, and special instrumentation. I have mentioned some few more objectives, but more or less they are the same. Compare complete evaluation of newly developed products, determination of process capabilities, so on and so forth. Okay, let me go to the second question. What it says, sketch and explain international prototype meter, Imperial standard yard. This was asked for 10 marks during, when was this? 2015. Yeah, sketch and explain international prototype meter and Imperial standard yard. This has been explained, right? Nevertheless, I can show you the international prototype meter and standard yard. Have a look. This is international prototype meter, okay, wherein you need to mention about the 16 mm width, 16 mm height, and then you need to define what international prototype meter is, whether it is a line standard. International prototype meter is defined as the straight line distance at 0 degree centigrade between the engraved lines of the pure platinum iridium alloy, that is 10% iridium, of 1020 mm total length, having a Tresca cross section. You can see this is called as Tresca cross section. Can you see this? Yes, this is Tresca cross section. As shown in the figure, the graduations are on the upper surface of the web, which coincides with the neutral axis. I will show you the photograph. The sectional shape gives the greatest rigidity for the amount of metal involved, and therefore is economic in the use of expensive metal. Okay. Imperial standard head. Can you see this? Imperial standard head. An imperial standard head is defined as made of bronze, 82% copper, 13% tin, 5% zinc bar, of 1 square inch cross section and 38 inches long. At a round recess, can you see this round recess? There are two recesses here. A round recess 1 inch away from the end side, two sides, is cut at both the ends up to the center. There are two holes, recess made at the from the ends, central neutral plane of the bar. Further, a small recess, again 1/10 inch in diameter, is made below the center. Two gold plugs 1/10 inch diameter having engravings are inserted into these holes so that the lines of engravings are in the neutral plane. I will show you the sketch. Can you see this? This is 38 inch and these are the two engravings, 36 inch at 62 degree Fahrenheit, and this is the neutral axis of the bar, and this is the small recess that is again made wherein the gold plug has been placed. Two gold plugs. Okay, bronze bar, it's a bronze bar, 82% copper, 13% tin and 5% zinc. And there are what is called as airy points. These are airy points. There is a question somewhere, I remember, what are airy points? This is also in your Viva questions or somewhere in the practical examinations. What are airy points? Are used for the precision measurement, metrology, to support a standard length in such a way that the minimum bending or droop of a horizontally supported beam occurs, and that is equivalent to, airy point is found out by root of L by root 3, that is 0.57735 inch of the length of rod, or you can say 1 by root 3 into L. If you have got a 1 meter length, you can find out where to place the airy points. It is 1 upon root 3 into L, whatever is the L. So 0.577 L is the distance at which the two airy points are to be from the center are to be plugged. Okay, let me go back to YouTube, see how many students have joined us. Okay, 10:16 a.m. there are 5 students now, 6 students. Are you able to see me properly? Is this okay? Just give me the feedback. Or you want the question paper to be uploaded? I'm trying to do that. It is giving some trouble. Do you want my question paper to be uploaded? I don't know what's happening with that question paper. I have tried uploading that. Just a minute, I'll try to add. That looks better. Yeah. Finally, I got it. Yes. So this posed some problem. Now I think this looks better now. Can you see the question paper? Okay, let us continue. Continue the question paper. What is the next question? Next question is, as I said, International Prototype Meter, Imperial Standard Head. Write the slip gauge combination to build the following dimensions using M87 slip gauge. Standard set is 49.3825 mm. Another is 87.321. So I have told you how to solve these problems associated. I have solved in my notes 49.3825. Let me just check. Go back to the notes. I will show you how this problem could be solved. Let me show. Wait. Let me see if I have the solution here. Can you see this? These are end bar problems. Okay. Let us solve. Let us take this example. Let us solve one problem here. Problem. See, this is a M112 example. Build a 58.975 using M112 set. Okay. Let me just tell you. Always start from the last decimal place. Then take subsequent decimal places. Use the largest possible block in each step. So, example, we will see what is M85. Before that, we need to understand what are the various slip gauge boxes available. Let's have a look. Okay. Now, the set given here is M87, right? Okay. M87 slip gauge. 1 second. Give me some time. Okay, can you see this? Okay, good. So now let me just check M87. The question paper says build a slip gauge using M87. Okay. Am I visible now? Is it visible? Okay, M87 step. M87 consists of these parameters. That is, range. There are 87 slip gauges. 87 gauges. Starting from last one is 1.000005 is one number. Next, we have 1.001 to 1.009. How many? These are 9 in number. Next, 1.01 to 1.49. How many are here? In this is in the range of 0.001 mm. This is anyway one piece. Next, these are 9 pieces. These are 49 pieces in the range of 0.01 mm. Okay. Next, 0.5 to 9.5. These are totally 19 pieces in the range of 0.5 mm. Okay. Next, 10 to 90 mm. These are 10 in number, totally in the steps of 10 mm each. These are 9 pieces, 10 mm each. Then totally you have 49 pieces, 87 pieces. 49 plus 150, 59, 69, 79, that is 8, and then another 9 here, 89, 87 pieces, 1 and 1 minus. So here 49 plus 9 plus 1 plus 19 plus this is 9. So what you get finally here is 87 slip gauges. So using M87 you need to build the slip gauge combination. Let us see, I think I have solved one problem. 92.357. Given question says 92.357 using 2 slip gauge, protection slip gauges using 2.5 mm each. What are end? But these are protection slip gauges are end gauges. Supposing you build these are your various combinations. You add a 2.5 mm end gauges. This is given as 2.5 mm and another is 2.5 mm. So you initially reduce the value by 5 mm and then build the slip gauges. Have a look. 92.357. First you delete that 5 mm straight away. Reduce. These are end bars. These are these are blocks which are wear blocks which are kept at the placed at the end. These are even in case of they wear out, they can be taken out. Instead of damaging the slip gauges, only the wear blocks are damaged. 92.357 minus 5. Next, what remains is 87.357. Then go to the last decimal. Always start from the last. So if you can, and one more important aspect in building the slip gauges is try to use minimum number of slip gauges. Okay. So this becomes 86.350. I have used 1.007, one slip gauge. What remains is 86.350. Can you see this? 86.350 because 1.007 is reduced. Now I have 1.350 in M112. I have 1.35. Use that. What remains is 85. Then finally 10. You reduce it by 10. Then you have one more 75 mm block. Therefore, the number of blocks that can be used, the slip gauges can be constructed is two protection slip gauges, 2.5 each. Next 1.007. Next 1.35. Again all those put together. There are 1, 2, 3, 4 and 2 slip gauges additional. Totally 6 slip gauges including end gauges. Now one more example, 35.4875 using M112. I think you can do that. Let us go ahead with next question. Okay, wait. Let me keep this fellow here. Let me bring this up. Okay. Now again let us see what are the other questions. Okay, good. Next question. We can build this. Please my important thing, next part. Determine the dimensions of the shaft and the hole for 30 H8 D10 and sketch the fit given all the values. Please all of you be careful now. I am going to solve this problem right here. Just let me see who all are online. 7 students, Musharraf, Abhishek, Chetan, Anant, Musharraf. I am going to solve. I will tell you the way to solve this problem given in the question paper. I will show you. I will highlight that first and then I will go ahead with solving the problem here using the drawing sheet. Okay. You have to be very attentive during this session. See that you are going to solve. We will solve this problem, and if you find any difficulty, you let me know right now. I will discuss it further, and it is also for the benefit of those who will view this video later. Let us see the question paper first. What the question says. Please read. Let me enlarge that first. Okay. Determine the dimension of shaft and hole for a fit of 30 H8 D10. Right. Let us solve it here. Let me write it down for you. Let me enlarge the window. Let me enlarge video capture window here. Okay, I can enlarge this. I will read the question for you, don't worry. Let us solve the problem. I will read the question paper for you. The question paper says, determine the dimension of a shaft and a hole for a fit of 30 H8 D10. 30 H8 D10. Let me see the alignment. Okay, it's visible, right? 30 H8 D10. Let me enlarge my view here. I can reduce this. Let me solve this. All of you please be attentive. This is very, very important. Okay. Let me discuss limits, fits and tolerance for this. Let us analyze the question first. It may take some time, but never mind. Determine the dimension of the shaft and the hole for a fit of 30 H8 D10 and sketch the fit given. What are the given values? Look, these are the things that are given to you. I is given 0.45 cube root of D plus 0.001 D. This is given. Next, what else is given? This is given in the question paper. You can see that. Next, upper deviation for D shaft is minus 16 d to the power 0.44. A. Next, B. Fundamental deviation for D shaft is given as minus 16 d to the power 0.44 d. Okay. And this unit is also given microns. Next, 30 mm. He has also given the diametral step. Diametral step has been given. It may or may not be given, but in this case it is given as 18 to 30. Okay. Observe one fact here. When the value is 30 mm, you need to consider the previous diametral step. If it is say 30 to 50, you need to consider 30 to 50 as the diametral step. Not next step is 50 to 80. Never ever use 50 to 80. Okay. Now clearly it is 18 to 30. So the question examiner himself has given you the diametral step, so no confusion. But even if it is not given, you need to remember this 18 to 30. Next, what is the thing given here is IT8. Let me see the camera position. Is it okay? Looks okay. Now, he has also given you IT8 as 25I. Next, IT10. IT10 he has given as 64I. Okay, all these things are given to you. Question says, determine the dimension of the shaft and the hole for a fit of 30H8D10 and sketch the fit. Okay, we'll solve this. I'll give you the theoretical way how to solve. Later on you can solve the problem by yourselves. Only thing you have to add the values. Okay. Let me see if this is visible to you people, and let me see the feedback. We can't see the problem, sir. I think it is visible here, 30H8D10. Musharraf, this is the problem, 30H8D10. I am not showing you the I am not showcase the question paper now. I am showing you the drawing sheet. Can you see it or not? Can you see this? This is very much visible. This is what is given in the question paper. Because the question paper was small and I need to switch over here, I have come here. If you wish, I can show you the question paper. Wait. I'll show you the question paper. Wait. One second, just hold on. Okay. Is it not visible? I am surprised. 30H8D10. Is it visible or not? Let me see what you people are saying here. Yes, sir. Okay, it is visible. Yeah, I was wondering what happened. Okay, so we'll continue. These are the things that are given to you. It's visible. Okay, good. So these are the, and be careful. I repeatedly am telling you how to solve this. Okay. Now let us get going with the solution. Okay, first let me start with straight away the sketch. Okay, let us draw the sketch. I will draw first the overall sketch. what is given, what is to be found out. Then you can solve the problem by yourselves. Okay, done. Let me keep it this way. Observe carefully. Let me make it horizontal for you people. Okay. H hole, it says 30H8. This is H8. He says D shaft. D shaft is below XY line. D10. Okay. This is hole. This is shaft. Okay. Now, what are we supposed to find out? We are supposed to find out 4 values. 2 values for the hole, 2 values for the shaft. Okay. This is given to you. This is 30 mm. This is basic size. Basic size. This is 30 mm. Okay. Now let us identify what are the things to be found out. This is 1. Basic size. Minimum size of the hole. Because it is EH hole, minimum size is always, minimum tolerance is, fundamental deviation for EH hole is 0. So this one, number 1 is equal to same 30 mm. Next, we need to find out number 2, that is the higher size of the hole, or the maximum tolerance for the hole, and then what is the maximum size of the hole. Maximum size of the hole is nothing but this value. Next, we need to find out the maximum size of the shaft, number 3. Next, we need to find out maximum size of the shaft, minimum size of the shaft, number 4. 1, 2, 3, 4, if you find out these 4 values, your problem is over. That's all. And how many marks? Please give me time. It gives you 12 marks. How much? 12 mark. Straight away pocketed, 12 marks. Okay, let me solve. Okay, let me solve the problem. So we need to hole dimension, that is 30, 0.000. Then we need to find out how much is this. We need to write it here. Next, shaft, we need to write that is equal to 30. One is this value. How much is this? Another is this plus this. How much is this? So if you enter these 2 values, you will get some values here. These are the things that we need to find out. 2 values for the shaft, 2 values for the hole. Okay. Now let us analyze what is given. 30H8 D10. H hole, it is on XY line. A to H holes, they are all having a positive deviation. Next, A to D shafts, they are all having negative deviation. Okay. This means that H hole is above XY line and the D hole is below XY line, or the basic size. We call as basic size it is, which means that this is a clearance fit. Even if you write, you will get 1 mark. Just by looking into this, you will be able to see. So this is a clearance fit. 30H8 D10 is a clear-cut case of clearance fit. Can you see the clearance here? This is the clearance. This is minimum clearance. This is minimum clearance. And this is maximum clearance. This is maximum clearance. Yes or no? This is minimum, that is minimum size of the shaft hole, maximum size of the shaft. This gives you minimum clearance. And maximum size of the hole, then minimum size of the shaft will give you maximum clearance. Right. Now, we need to find out 1, 2, 3, 4. Let us solve the problem. First, let me solve hole. First, hole dimension. Prior to that, we need to solve these 2 parts. Very important. Step 1. two parts. Before solving any numerical, we have got to follow two steps. Step 1, find out d is equal to root of d1 into d2, that is equal to root of 18 into 30, and you get the value in terms of here mm. Whatever is the value, please find out later. I don't know how much is this. I have not solved this problem, but I'll show you the methodology. Okay. Next, step 2. Step 2, you need to find out I is equal to, already the formula is given. You don't have to remember, but it is better we keep this in mind. If it is not given, you should be able to reproduce. I is equal to 0.45 cube root of d 0.001 d. Okay. I think it is already, what's the time? 10:51. We are exceeding the time, but never mind. Are you ready to continue beyond 11 o'clock, or you want to stop me? You want me to stop here by solving this problem? Please message me so that I can stop it here. Once I solve this problem, I can stop the question paper discussion. Just give me the feedback. Meanwhile, I'll solve the problem for you people. Okay, I is equal to 0.45 cube root of whatever the, let us say this value as 18 into, I'll find out how much is that. 18 into 30 square root. Just give me time. How much is this? Can anybody tell me? Square root of cube root of, right? What is that? 18 into 30. One sec. Yeah, this is 23.23 mm. This is equal to 23.23 mm. So you should be able to write 23.23 plus 0.001 into 23.23. And please note, the value you get here is in microns. Very, very important. Value is 0.001 mm. That is 1 micron is 0.001 mm. Did you understand this? Find out this value meanwhile. 0.45 cube root of 23.23 plus 0.001 into 23.23. Whatever is the value, you write it. I don't have time to discuss this now. I don't have solution. I will have to do this using a mobile calculator. Nevertheless, you can do that. Ping me the message. I'll tell you. Next, continue the problem. Once you know these two steps, straight away two values of whole are found out. Okay, let me see. This is given. This is given. EH. How much is this given value? Question problem says EH8. Okay. So IT8 is equal to, he has given already IT8 as 25I. Do you know? It's already given 25 IU. That is equal to 25 into I value. Did anybody get how much is this? Let me just check. How much is this value? 0.45 into bracket. How much is that? 23.23 brackets complete raised to cube root of 1/3, right? How much is this value? Okay, plus it's very difficult to use this 1.283. No, it's very difficult to manage mobile calculator here. Anyway, please find out this. I'm not able to get this value. You enter that value here, 25i value. Once you get, you should be able to get 25i. Did anybody get? Let me check how much is the answer. Continue, sir. Okay, good. Thank you. Thank you, Kpifik. Can you tell me how much is this answer? Can anybody tell me how much is this value? I want to know how much is this answer. How much is this value? I don't have calculator here. This is posing a trouble. .307. Just check this answer. Is it correct? 1.307 microns. Can anyone confirm me this value? Can anyone confirm me this value, please? Answer you get here is in terms of microns. Okay, let us assume it is 1.307. Okay, so now this becomes, we'll continue this part, 1.307 microns, that is equal to 25 into 1 micron. This becomes 0.001 307 mm or 0.001 mm. That's all. 1.3 micron, 1 micron, 0.001 millimeters. Okay. So this becomes 25 into 0.001 mm. So what you get here is the value 0.025 mm. That's all. Okay. Now this is one value, that is 30 mm, already given. This is 0.025 mm. 25 mm. So obviously the second value here is, number 2 here is 30.025 mm. So the two values of whole are 30, 0.000, 0.025 mm. That's all. 6 marks. Straight away. All values in mm. No calculation. Now let me go to shaft value. Okay. Shaft dimensions. Okay. Let me draw the sketch for the shaft. This is the D shaft. This is D10 shaft. Okay. So we need to find out third value. This is number 3 and this is number 4. If you find out these two values of shaft, third and fourth, the problem gets solved. Okay. Now, how much is this? This is called as fundamental deviation for D shaft, which is given as minus. It's already given in the numerical. Look. Look. Can you see this? Fundamental deviation minus 16d to the power 0.44. It is already given in the exam. You are not by hearting this, not necessary. It will be given normally. Fundamental deviation for D shaft is minus 16d to the power 0.44, where D you have to substitute in mm. Okay. The answer you get is in microns. This is very important. You need to substitute the value of D in mm. You get the value in microns. Okay. Minus minus 16 d to the power 0.44. How much is the value? Find out. At the today's, I may not be able to solve. Had I solved it earlier, I could have given you. Okay, now all you need to do is fundamental deviation for D shaft you identify minus 16. D value we have found out as 23.23. Okay, 23.23 minus d to the power 0.44. Whatever is the value, you mention that here. How much is that? You write it here. And next, D10, where IT10 is the tolerance, is given as, have a look, IT10 is already given as 64i. I'm not remembering, it's already given. IT10 is 64i. Okay. So IT10 is equal to 64 into I. I is nothing but 64 into, we have found out 0.001301 mm, or I can say 0.001 mm, or it is also equal to 0.064 mm. Got it? That's all. So we know this is 0.064 mm. All we need to find out is number 3 is equal to, that is maximum size of the hole, 30, number 3 value, 30 minus fundamental deviation, this value. And number 4 is equal to 30 minus fundamental deviation minus 0.064. Please find out these values. You should be able to get the answer. All the 4 values are over. Problem gets solved. You should be able to get, say, something around 29.2, 29.3. I don't know how much it comes out to be. This is how the problem is solved. A quick recap of what is to be done. First, draw the sketch. The given problem is 30 H8 D10. Draw the sketch H8 D10, and this is the fundamental deviation for D shaft. This is H, for which there is no fundamental deviation. Okay, we need to find out, one is minimum size of the hole, second maximum size of the hole, third minimum size of the shaft, fourth this is third is maximum size of the shaft, fourth is minimum size of the shaft. These are the 4 values we have to find out. Before finding out any values, we need to do 2 computations. One is find out how much is D. Second, find out these two. First, find out how much is D. D is given as square root of diametral step 18 into 30, and you get the value in terms of mm. Here in this case it is 18 into 30 comes square root 23.23 mm, if my calculation is right. Next, step 2, I, fundamental tolerance I is 0.45, cube root of D plus 0.001 D. So you find out this value. D value we have already found out 23.23. Finally what you get is 1.307 microns. I think this problem I have solved in my notes. Have a look into that, or maybe other day I solved this problem also. I remember having solved this. Let me just check if I solved this. Let me just check if this problem was solved. No, I have solved the other one, I think. These are all the previous solutions I have done in my earlier classes. Now it is, I have solved 25H8D9. The problem I solved is 25H8. This is the problem I solved. 25H7F8. This is the problem I have solved. Can you see this? Okay. Now, once you are done with these 2 important parts, that is finding out D and then I, this will get you 4 marks or so, maybe 1 mark here, another 1 mark, 2 or 3 marks definitely you should be able to get. Next 2 parts, that is you have to find out the hole dimension. What are the hole dimensions? Let us calculate that. Okay, here hole dimension. Hole is H8, find out IT8 is 25I, that is equal to 25 into whatever the I value you substitute, you get 0.025 mm. You write that here. This is a tolerance for hole. Okay. Now, one value of hole is 30 because minimum dimension is the fundamental deviation is 0. So the minimum dimension of the hole size is 30 mm. Okay, H8. It cannot come below 30. Next, another value, this minimum value plus tolerance, that is 30 plus 0.025 mm. Okay, so two values of hole are represented as 30.000, 30.025 mm. Okay, next, that's it. Go ahead with the shaft part. Yes, have a look. Shaft part, draw the sketch. Shaft is below basic line size. FD is minus 16 d to the power 0.44. It is already given in the numerical. All you need to do is substitute d value, you should get this, and once you get this, you get the fundamental deviation. So 30 minus this size, or this gets, what you get here is in microns. Please note the answer you get here is in, d is in mm, and answer is in microns. This is a mistake we do. Normally students do this. They substitute this in millimeters and find that the answer is in mm. No, answer is in microns. Okay, FD is d to the power, but this is in whatever the answer you get. Next, D10 means IT10 tolerance. IT10 is given as 64i. It is given in the numerical. You don't have to remember. It's already given in the problem. Okay, that is, find out how much is 64i. That is 64 mm. Write it here, 64. Now, remaining, we need to find out the maximum size of the shaft. Next, minimum size of the shaft. Maximum size of the shaft is nothing but this 30 mm, total 30 minus FD. Next, this value. This is nothing but 30 minus this plus this. 30 minus FD minus 0.064. You find out how much is the value. All the four values are got, and you get straight away 12 out of 12. See that you reach third decimal all the time. Third decimal. Don't shortcut or don't reduce the value. All values will tend to 30 then. That is a blunder mistake that you do. Please don't round off to second or first decimals. Go reach up till third decimal in case of gauge design, in case of limits, fits and tolerance. For gauge design, you need to reach up to fourth decimal. Always please see that you do this. Okay, let me see. Go back to YouTube. How many are here online? 7 students. Sir, always we have substitute mm and answer should be in microns. Right, correct. All the time, all time. Look, I'll solve this. I'll tell you one, and don't confuse here. There are two parts. Good question. One sec. Who is this who has asked? Anant, right? Who is this? Anant. Sir, always we have to substitute in mm and answer should be in microns. Just wait. After decimal points, how many digits should be right? Okay, both are good questions. First part I will address now. Look at this. Look at this part. Here, D has to be substituted in for finding out the normal nominal diameter. Both are in millimeters. So 18 into 30. The answer you get here is in millimeters. No change. This size, this number is fixed, 23.23. It is in millimeters. Keep that in mind. I will write it in a separate piece of paper. Wait. Let me clarify the doubt regarding units. First, D, root of D1 into D2. Okay, this is in mm, this is in mm, and answer you get here is in mm. Keep this in mind. Okay, next, I value 0.45 cube root of D plus 0.001 D. Please note, here this is in mm, this is also in mm, but answer is in microns. Got it? Say this is In the present example, it is 23.23. In the present example, it is 23.23 mm. Again, you substitute 23.23 mm. You get an answer as 1.307, I think. You get 1.307. And what is this? You get 1.307. As I said, 1.307 is the answer you get in microns. That is equal to 1.307 microns is equal to 0.001307 mm. Or you can round it off to third decimal. Second question that has been asked, how many decimals? 0.001 mm. Okay, is this clear? Answer you get here is in microns, 1.307 in microns. Now that convert into millimeters, 0.001 mm. Keep this in now. Next, let me go to next part. I will compare one with another. Okay, these two decimals. Next, third, fundamental deviation. Fundamental deviation for D shaft is equal to minus 16 d to the power 0.44. Okay, here please note this is again in mm. Value of D is given in mm and answer you get here is in terms of microns. Okay, I will write it for you. 0.16 into 23.23 raised to 0.44. This answer, whatever you get, is in microns. Whatever you get is in microns. Let us, I don't know how much is that. Find out. Let me say it is let me say 22 microns. Please don't follow this. It is only reference sake. So supposing answer you get is, answer you get is 22, and this 22 is nothing but 22 microns. That is nothing but 0.022 mm, and this is the number we need further. Fundamental deviation. I think I have made very clear here. Okay. Next, second question is, how many decimal places we need to reach up to third decimal, 0.002, in case of limits, fits and tolerance. But in case of gauge design, we need to reach up to fourth decimal. Okay, with that, having said that, the problem gets over. And tolerance, yeah, another is fourth number value, IT5, IT8 is equal to 25i, right? Here, now what is being substituted? Here, if you substitute I in terms of mm, answer you get in terms of mm. Answer will be in mm. But here, if you substitute I in microns, obviously IT8 will be in microns. Finally, you need answer in terms of millimeters only. IT8 or IT10, 25i, 40i. So depending on whether you substitute I in terms of millimeters, you get net value in millimeters. I value substitute in microns, you get this in microns. Here I value in millimeters was 0.001 mm. Here in microns it was 1.307 microns. Now you can say as 25, let us say, let me call as 1 micron. Let me call it as 0.001 mm. Okay. Either it is 25 micron is the answer, or 0.025 mm is the answer. Either 25 mm or 0.02. Ultimately, we require this number. We don't require micron number. Okay. Please note D, mm, I, you get in microns. Convert that into millimeters again. You convert that into millimeters. Next, third one, fundamental deviation either for the hole or for the shaft. You substitute d value in millimeters and the answer you get in microns, minus 16 minus I minus 16 23.23. Again this is in mm and the answer you get in terms of microns. Next, let us say the answer is 22. I don't know. You get by this calculation, let us say that this is 22. And what is the 22 you get? It is 22 microns. If it is the case, 22, 30, 22.07, whatever is the micron value. So I have to convert that into millimeters, 0.022 mm. Okay. Next, IT values, IT8, IT9, IT10, that is equal to 25i, 30i, 40i, whatever is the value. If you substitute I here, look, I, can you see? If you substitute in millimeters, you get the answer in millimeters. If you substitute in microns, you get in microns. And finally, I need the answer in millimeters. Now let me see how many are online. 9 students are online. Up to 3. Yeah, right. Up to 3 digits. So I suppose, can you please tell me if you are through with this example? Just message me if you are happy and the solution is over. You can solve rest of the part. You can note down, try solving this using the calculator. For me, going by my mobile and doing the calculation is difficult. So you find out how much is the answer. Okay. Can I go ahead and see the rest of the question paper? Just ping me. Do you want me to, somebody said already continue. Okay, 1.307 mm, good. That's fine. That answer is right. Right. Yes, sir. Thank you. Sir, clarified. Good. So let me continue with the rest of the questions. Okay. Hubbali, thank you. Now that's okay. Now, can I continue with the next part? Is the problem clear now? Did you understand the problem? Good. Musharraf Desai, he has messaged, everything is good and I can go ahead. Let me see, read the remaining questions. This is the one which takes more time because I am solving the problem. Okay. Now, let us go ahead with this problem. Wait. Right? Okay. Look at the question paper. Please follow the question paper. I will enlarge the question paper for your benefit. And can you read the question paper here? See, fundamental deviation is 0. He has not mentioned for what. Fundamental deviation is for H shaft it is 0, H hole it is 0. If you make a mistake, it's additional information that is given to create confusion among you. It is not necessary. 30 H8 D10 is sufficient. H hole has fundamental deviation 0 and D shaft fundamental deviation is given as minus 16 D to the power 0.44. So this sixth information, point number 6, is a confusion creator for you people. Sketch the fit. I have drawn the sketch. I can draw it once more for you. Please let us draw the sketch. One sec. Final sketch. Let me draw the final sketch for you people without any confusions. Let me draw. I will take out all the papers. Okay. I will draw the sketch for you people. Please understand this. Okay. Please follow this. H hole, H8. Draw the sketch in the examination. Start with the sketch. Next, D10. Now we need two values. One value of hole. Next, second value of hole. Okay. And this basic size is given as 30 mm. Can you see all these things? Okay. This is 30 mm. 30 mm given in the problem. So first value is 30. Second value you have to find out IT8. IT8 is equal to 25i. I is equal to 0.45 cube root of d plus 0.001d. and d is equal to root of d1 into d2. This is in millimeters and this is in microns. Convert that into millimeters. Convert. Okay. Add that value here. How much is this in terms of millimeter? Straight away. Now, this part is over. First, you can find out. Once you know this, you can calculate this and you can find out number 2. Next, come to the shaft part. Fundamental deviation. Fd is equal to minus 0.45 cube root of d plus 0.001 d. Find out how much is this. This you get in terms of, answer is in terms of microns. Convert that in terms of millimeters. Answer you get in terms of microns, convert that in millimeters. Okay. Now, we need to find out number 3. Next, number 4. This is maximum size of the shaft. This is minimum size of the shaft. Okay. You can find out 3. 3 is equal to 30 minus fundamental deviation. Right? Third value. 30 minus fundamental. Next, fourth value. 30 minus fundamental deviation minus this value. How much is this? This is IT10. That is equal to 40i. I don't know. I think it is given as 40i. Find out how much is this 40i minus IT10. That's all. All 4 problems, all 4 values are got. This is the sketch and you write down the values of hole dimensions 30.00, this is 0.000, I don't know how much is 0.001 if I am not mistaken. Next, shaft dimension 30, one value is some minus 0 point something, another is also 0.00, I don't know how much is this, just check. 30 minus, this is one value, 30 minus this value and 30 minus this value, this plus this. One is 30 minus this, another value is this total value 30 minus this minus this. So these two numbers you have to write. 30 minus this minus. One is upper deviation, upper tolerance, higher tolerance, another is lower tolerance. Okay. I think I'm getting exhausted by this lecture. Footballer, message retracted. Continue, sir. Okay, epic. Thank you. Let me continue fast and bring it to an end. Okay, list and explain different types of fits. Great. This carries 8 marks. Wait. Okay. Please read. With a neat sketch, explain different types of fits with examples, 8 marks. There are 3 types of fits, transition fit, interference fit and clearance fit. Try to give examples for each of those fits. I have explained in my notes. Please go through that and draw the neat sketch of 3 types of fits. Next, list the characteristics of comparators. Comparators I have not studied, I have not discussed now in this lecture. Maybe in tomorrow or day after in subsequent lectures we can discuss about comparators. So it's a theoretical question carrying 5 marks straight away. Next, explain the example, the construction and working principle of Johansson microcator. Yes, we are going to discuss in the comparators Johansson's microcator, unit number 5. Please be ready. I will discuss that, or maybe madam is going to discuss. Sketch and explain will give you straight away 10 marks. Straight away. 5 marks for the sketch and 5 marks for the explanation. Simple explanation. Next, list and the advantages and disadvantages of optical comparators. Yes, what are the optical comparators? What are the advantages? What are disadvantages? We will discuss that in our unit number 5. Then, explain with the help of a neat sketch the method to measure minor diameter of the internal. One second. Let me move this question paper a bit. Okay. Okay. Can you see this? explain with the neat sketch the method to measure the minor diameter of the internal screw thread using taper parallels and rollers. Please let us discuss this during our discussion on the sine bars. Then we are going to discuss on dial gauges. Then we are going to discuss on caliper. There are some 2-3 topics that we need to discuss in Unit 5 comparators. There we will be taking up this question. Let's see if possible. Next, there are an expression for the best size of the wire, 3-wire method. I don't think it is there for a present syllabus. This is a previous syllabus, so let us not worry about it. Next, what are the various types of errors in screw threads? Please don't worry, this is not from this. This is the old syllabus. Okay. Next, neat sketch. Explain 3 stages of generalized measurement system. Yes, stage 1, detector transducer stage. Stage 2, intermediate modifying stage. Stage 3, readout stage. I think this was even your first IA test also. The same question was being asked. This carries 10 marks. It varies from 6, 8 or 10 mark. Simple sketch, 3 parts, generalized measurement systems, input, stage 1 detectors transducer stage, stage 2 intermediate modifying stage, stage 3 readout stage. Next, explain with neat sketch capacitive transducer of changing area and the changing distance. Each of them will carry 5 marks each. One is changing area type, another is changing distance type. You need to write the equation for capacitance. It depends on the 3 factors: area, cross section, diameter d, and the distance between the plates. You mention these, and the 2 values have been changed here. One is area of the plate, another is changing distance. I think I have discussed this in the class. You can go through that and write down those 2 transducers. Next, with the neat block diagram, explain CRT, cathode ray oscilloscope. We have seen cathode ray, the functioning. We have seen the animation of cathode ray oscilloscope. Please go through that. Next, XY plotters. Yes, we don't use them XY plotters nowadays, but we have got high-end printers and LJet printers, fast printers. So we seldom use XY plotters, but nevertheless you can go through that XY plotter sketch and then explain how it functions. Explain Prony brake dynamometer. 10 marks straight away. We can sketch and explain what is the Prony brake dynamometer. Find out how much is the torque developed, that is force into perpendicular distance, that you can write. Okay, part B is over. Next, let me just check if this can be moved. Next, explain Prony brake. McLeod gauge. What is sketch and explain McLeod gauge? You need to write down about what is a McLeod sketch. Carries 5 marks. Explanation carries 5 marks. Then you need to write down the Boyle's law on which it is functioning. That is P1 V1 equals P2 V2. What is P1? What is P2? What is V1? What is V2? You need to write about that. Next, mention a point about and draw the sketch properly. Don't make the mistake of keeping the capillary tubes open. One is closed, another is the smaller capillary tube is closed, the larger one is open. You need to keep that in mind. Optical parameters I discussed in yesterday or day before class. Next, gauge factor, yesterday's class I discussed. Bonding methods I discussed yesterday. Thermocouples, yes, I discussed the previous day. And what are the bonding materials, I have discussed all those. Okay, thank you friends. This is one question paper that we have discussed today. What is the question paper that we discussed? This is today's question paper was on December 2014 January. That is December January 3rd semester B mechanical measurements and metrology. There are 1 or 2 questions which are not from the present syllabus anyway. Not worry. Why not next diametral step? Oh, there is a question. Why not next diametral step? See, between 30 to 50, 50 to 80. Got it? We are going to use the nominal diameter. Our diameter in the present case is how much is that? 30 to 50. Let us say if the given value is 25. Let us assume 25 H8 D9, 25 H9 D10. If you use, anyway this 25 is lying between 18 and 30. So that is, there is no issue at all. But now when you consider 30 and if you take the next diametral step 30 to 80, 30 to 50, the D value will be more than the actual size. Look, 30 to 50, if you consider that size, the obviously the answer square root of 30 into 50 will be somewhere around 35, 36, 37. Our shaft size itself is 30 or the hole size is 30. So how can the nominal size go beyond that? It has to be either equal to or less than 30 mm. That is the reason we don't go to the next diametral step. We use the previous diametral step when the diameter is exactly at the juncture of 2 values, that is 1 to 3, 3 to 6, 6 to 10, 10 to 18, 3 to 6, 6 to 10, 10 to 18, 18 to 30. Yeah, if it is either the value is 18 or 30 or 50, 30 to 50 or 80, we use the previous step. I think the point is very clear now. I made clear. We have to take the previous diameter. Yeah, Anant, you are right. We have to consider the, if it is exactly falling on the line. Let me clear that. One sec, please. Check this. Okay, this is visible. Let me clear this. If given size is 30H8D9, this is 18 to 30 diametral step. If the given size is 50H8D9, you have to consider 30 to 50 and not 50 to 80. You should never consider this. Next, if the given value is 25H8D9, no ambiguity, straight away you have got 18 into 30. No ambiguity. 25 lies between the range 25 to 30, 18 into 30. No ambiguity. Got it? Only the problem comes when the value is exactly on the changing values. Diametral steps are 1 to 3, 3 to 6, 3 to 6, 6 to 10, 10 to 18, 18 to 30, 30 to 50, 50 to 80, 80 to 120, 120 to 150, and 150 to 300. Next is, I think, 300 to 500. I am not very sure, but more or less, if my memory goes through, these are the diametral steps. And most of our engineering calculations, we reach only up to say 50 to 80 mm. We don't go beyond. 80 mm is the diameter of the whole of the shaft. So unless you have got specific applications which you require a diameter more than 80 or 100 mm, then we go to the next steps. But most of our values lie somewhere around 18 to 30 mm, 30 to 50, not more than that. Okay. So thank you all. It has been a marathon session. Only last 2 hours remaining. Let me stop. Even I'm done for the day. 11:30, 1.5 hours continuously I've been speaking. Thank you all. In case we will solve next. Do you want me to continue tomorrow? It is a difficult task for me, but if you wish, I can live stream tomorrow also. Next question paper. Do you want me to discuss? Just mention. Do you want me to solve another question paper, or do you want me to solve a numerical on gauge factor, gauge tolerances? Do you want me to do that? Otherwise, we can close the sessions. Please note, it requires a lot of patience and a lot of preparations for doing all this. And if it is worthwhile, I don't mind. I can always continue. Or you want me to take up a special topic? Please let me know. Just message me. What should be our agenda for tomorrow? Yes? What should be our agenda for tomorrow? Do you want me to? There are many question papers that we can still discuss. Do you want me to discuss question papers? Just send me the message. Otherwise, I can stop the streaming. Continue, sir. Chetan, you say, sir, on building slip gauges, only one problem. Okay. I can do that. Oh, sorry. What happened? Hello? Am I online still? Am I online still? it got disconnected. Slip gauge problem. I can solve tonight. Okay, don't worry. I will solve couple of questions tomorrow, couple of numericals on slip gauge building. It should be easy. Okay, today I will keep the today I will solve problem. I will keep the solutions. Discuss tomorrow by 10. Anything else? Anything else that you want me to discuss tomorrow? 7 concurrent views. Who are those? From which places you all have joined? There are some 2-3 people. Chetan is regular, and then Salunke, Musharraf Desai, then Abhishek, Epic, then Chetan Kumar, yeah, Anant Nadagowda. I think most of you are all creepy freak. Continue, good. Definitely I will do that. So tomorrow I can, I have taken your feedback. So tomorrow we are going to solve. Yes, wait a minute. Wait a minute. Let me write down the tomorrow's agenda. Okay, tomorrow's agenda. We have to be very, very clear what we do. 23rd 04 2020. Okay, today is Wednesday, Thursday, 10 a.m. Agenda. Okay, 1. Slip gauge numericals. Or building slip gauges. 2nd, continuation of question papers. Okay. Is this all right? Tomorrow's agenda. 23rd 4/2020 10 a.m. Today's date is 22nd. Okay, slip gauge numericals, and then question papers will be discussed. Let me see what is your response. I'm online. Okay, what are your responses? Yes, question 7, discuss once again tomorrow. Oh, what is the question number 7? Let me just check. Wait, question number 7. Oh, I see. Wait. I will show you. Okay. Question number 7 is explain Prony brake dynamometer with neat sketch, and with a neat sketch explain McLeod gauge. Okay. Tomorrow I can do that. I will show you both. Now I think I am a bit exhausted. Please excuse me for today. Prony brake dynamometer we are going to discuss tomorrow. I will show you McLeod gauge also. I will show you. And we will, because those questions are again appearing in remaining set of question papers, so we will certainly discuss those. Don't worry. Yeah, definitely we will look into this. Question number 7 you have discussed Prony brake dynamometer with neat sketch, then explain with neat sketch McLeod gauge. Both the questions can be solved very easily. I will upload that PDF file. I will showcase both. By tomorrow 10 a.m. I will be ready with your question regarding, yes, so I will add that in the agenda. One sec. I will add that in my agenda. Okay, let me add it in. Number 3rd, what is that? Prony brake dynamometer. Prony brake dynamometer. Brake, B-R-A-K-E it is. Next, what is that? Mech gauge. So this will be discussed. B-R-A-K-E, not B-R-E-A-K. Prony brake is different, brake is different. Okay. Next, Chetan Kumar, thank you. Abhishek Salunke, yes sir. Tomorrow I will discuss, no problem. Okay. See you all then. We can finish up the day for today. We have shown you all the three or four agenda that we are planning. One is slip gauge numericals, then continuation of the question papers. Before that, let me continue with the Prony brake dynamometer and then Mech gauge. By tomorrow, this will be discussed. Okay. In case you have anything else, we can also further. Thank you. Thanks a lot. It was nice meeting with you all people, and then of course good interaction we had. You can circulate this. This video gets uploaded now onto YouTube. Your friends can view that offline, not an issue. And let us have some good interaction even by tomorrow, by 10 o'clock. Some problems we faced today in the beginning. Fortunately, everything got fixed. These are quite likely to happen. Can you see this part? And then so many arrangements. I think there was an issue with this. Initially, the audio that you were facing the trouble was probably with this microphone. I need to keep it away and check the connections. By 9:55, 9:50, I will send out the streaming link to you. Thanks to Professor VK. You can also put him a word or in your WhatsApp messages. Thank him for giving me this, circulating this link. Thank you all of you who have joined, and hope you are doing, you are keeping yourselves fit and safe. Be inside the homes all the time. See that if at all by emergency case you need to go out for some essentials, always keep yourself safe. Wear the mask. Follow the safety precautions. It's in our own good interest that we need to follow all these things. Let us follow the social distancing, and at the same time, let us keep ourselves fit and energetic all the time. I keep saying about this. Let us learn new things. Let us understand new concepts. Let us go for some new software. Then, of course, we have our day-to-day courses that we can think about. We can find out now. This is a high time that you can identify some good projects for your the present scenario has opened up many projects for your final year, so that you can think now. Keep in a note. The idea is always very important. Keep an idea, write it down in a notepad. See that during final year or pre-final year, you can start working on those. Try to learn something connected. Maybe your Python or some software that is needed for your furthering of your knowledge, that you can try now. Still you have time, sufficient time. Please don't waste time. You have your other WhatsApps, Facebooks and Instagrams, and do that well and good. But I find this time to be very, very useful for me to learn new things. That's good. Okay, let me see what are your final comments. Thank you. Rutik Mentse, Chetan Kumar Hebalde, Abhishek Salunke, then who are all online. Those who, thanks a lot. Good day. Bye. Take care.